Hello all. In this video we will be learning how to convert general form of an equation to normal form of an equation. In the first lecture we learned that a general form or general equation of a plane can be written as ax plus by plus cz plus d is equal to 0 provided at least one of them is not equal to 0, right? And in the second lecture we learned about the normal form of a plane, that is lx plus my plus nz is equal to p, where L, M and N are direction cosines of the unit vector perpendicular to the plane, and P was the perpendicular distance from the origin to the plane. And we can actually rewrite this particular equation as Lx plus my plus nz minus p is equal to 0. So if you see, the general form and normal form almost looks similar, right? So these two can become identical if their coefficients, if the ratio of their coefficients are equal to 0. Sorry, if the ratio of the coefficients are equal. That is L by B by M by B, which is equal to N by C, and that also should be equal to minus P by D. Comparing the first and fourth, second and fourth, and third and fourth, we will be getting L is equal to minus AP upon D, M is equal to minus BP upon D, and N is equal to minus Cp upon D. So now let's square all these three equations and add them. So we'll be having L square is equal to A square P square by D square, M square is equal to B square P square by D square, N square is equal to C square P square by D square. I'm not writing that step, but assuming that we all understood that step, squaring all the three equations and adding them, we will be getting L square plus M square plus N square is equal to p square a square plus p square b square plus p square c square. So taking p square common outside, I'll be having a square plus b square plus c square the whole upon d square. But in the previous classes we have learned that L square plus M square plus N square value is nothing but 1. The value of L square, M square, N square turns out to be 1. That means p square can be written as just a minute. P square can be written as d square upon a square plus b square plus c square. Right. So again, taking square root on both the sides, we have p is equal to plus or minus d upon root of a square plus b square plus c square. So now we have two different signs. So we know that since p is a distance, p is always going to be positive, right? P is always positive. So we have to choose the sign based on the sign of d. So whenever d is negative or d is positive, let's start with positive. Whenever d is positive, we choose a positive sign. In that case, we have whenever d is positive, I think this is not coming on the board. So whenever d is positive, we have our p to be, we choose the positive so that our right hand side remains positive. So we have d by root of a square plus b square plus c square. And whenever d is negative, we choose negative sign. So that we have negative times negative becomes positive. So we maintain that p value is positive. So whenever d is negative, we have p is equal to minus d upon root of a square plus b square plus c square. So for d positive, we have P is equal to D upon root of A square plus B square plus C square. So substituting the value of P in L, M and N, we get the values of L, M and N. That is minus A upon root of A square plus B square plus C square, minus B upon A square plus root of A square plus B square plus C square, and N is minus C upon root of A square plus B square plus C square. And on the similar context, whenever we have D to be negative, we know that P is going to be in this case. So the value just becomes positive. So substituting a value of L, M and N in the equation Lx plus My plus Nz is equal to P, we get this when D is positive and this when D is negative. So obviously we did get different values of L, M and N for depending upon D is positive or negative, right? So whenever we are given with a general form of an equation, we can always reduce it to the normal form depending upon what is D, whether it is positive or negative. And choosing the appropriate formula, we can actually get the normal form of the given plane using the general form of the plane.